Hello there, and welcome to my video on the distance formula. At the start of the video here, I'm going to be doing a quick little derivation to show you where we can derive a formula which gets us the distance between any 2 points on a coordinate plane, and then we're going to do some examples. So let's suppose I have the point, the point in general, let's say A, which has components x1, y1. So these could be anything. That could be like 1, 2, or it could be 1,000,002 or whatever, you know. And this point here, we'll call x2, y2, which again can be x2 and y2 can be anything you want. So these are two, they could be over here, it could be anywhere, okay? And we're going to connect these with a straight line like that. And then what I'm going to do is impose a right angled triangle on this straight line setup, just like this. And I'm going to call this distance D. Alright, so I want to find this distance. Now, as I already showed in my, I believe, the previous video with the angles between the line and the x-axis, that this side here, length, can be represented by y2 minus y1, and the length of this side can be represented by x2 minus x1. So here we have a right angle triangle. We have two sides defined, and we want to have an expression for the third one, and I hope we would know that this is Pythagoras' theorem. So Pythagoras' theorem states that c squared, where c is a hypotenuse, is equal to the sum of the squares of the other two sides, the two short sides. Okay, so in this case, c, the hypotenuse, is d, so we have d squared equals, a is, well, you can pick any one to start with. I'll pick x because we normally go xy, so we'll say that's x2 minus x1 squared, because this is a, and we put this in a bracket because it has to be the whole thing squared, plus b, which is the other side, y2 minus y1, y2 minus y1 squared. And this is normally the way that I leave it. In fact, what I've noticed, most people tend to write it this way instead, where we have distance is the strictly positive square root, so we don't need any plus or minuses here because of the geometric interpretation. Square, and then this big square root. Personally not a fan. I like to put the square root at the end like you do with any other Pythagoras question, just so you don't have to write this big square root every time, but suit yourself. But in either way, this is the distance formula right here. So let's look at an example. Here we have the point U minus 2, 5 and V 1 minus 3. And what I'm interested in is finding the distance between U and V. So again, we're going to get our distance formula, and I will write this as d squared equals x2 minus x1 all squared plus y2 minus y1 all squared. So this is the difference in x plus the difference in y squared. Alright. Okay, so x2 is 1 and x1 is minus 2. So we're going to have 1 minus 2, and then all of that is then squared, plus y2 is minus 3 and y1 is 5, so we have minus 3 minus 5 all squared. This equals, so 1 minus 2 is 3 squared, and minus 3 minus 5 is minus 8 squared, and 3 squared is 9, minus 8 squared is positive 64, and 9 plus 64 is 73. But we're not done, because this is d squared, so then d equals the square root of 73, and we're going to leave it like this. So normally when we're in National 5, we would maybe plug this into a calculator and get some kind of like maybe 2 decimal places approximation. We're in higher now, so we tend to leave things as so-called exact values so that we can get the most precise answer possible. In this second example, we're being asked to prove that the point P34 lies on the circle with centre 1, 2, which has a radius r equals the square root of 8. So let's kind of visualize what's going on here. So if I give myself a circle as best I can, here we go. and the center will be approximately here. And so we're saying that the center here is the point 1, 2. And if you connect a radius, then this radius would be the square root of 8. And that would be the same, of course, for whichever radius you draw. So we're being asked to show that the point 3, 4 lies on the circle. I should say the circumference of the circle lies on the circle. So that would be here. So if it's true, then it's going to sit right there. 3, 4. All right. So let's prove that. So we're going to get the distance formula because, again, we've been given 2 points. And we're thinking about the distance between these 2 points, because if it wasn't the square root of 8, let's suppose that we find the distance and it's like, I don't know, 10 or something, then that would be a way over here. That would be outside the circle. And similarly, if you found the distance with, let's say, 2, then it would be inside the circle. It wouldn't be on the circle, which is what we're being asked to find. So the distance formula states the following, and when we plug these numbers in, we get 3 minus 1 squared plus 4 minus 2 squared, which is 2 squared plus 2 squared, which is 4 plus 4, which is 8, and then that's d squared, so d is the square root of 8. Since d, which is the distance between the point and the centre, is the square root of 8, and the radius is also the square root of 8, the point P lies on the circle, as required.